Hello friends, welcome to my channel. Let's have a look at the daily challenge problem, problem 235, lowest common ancestor of a binary search tree. So in this video, we're going to present two solution formats, one in recursive format, one in iterative format. So this problem requires to return the lowest common ancestor of two nodes in a binary search tree. So here the main point is that we need to take the binary search property into consideration in the coding. So let's look at the examples. So in example 1, so 2 and 8 are in the left subtree and right subtree of the root 6. So 6 is the LCA. And in example 2, so 2 and 4 are the two nodes, and 4 is a descendant of 2, so we return 2. So similarly, we can interpret example 3. So before we do the analysis, let's look at the constraints. So the constraints are actually important for us. So first, the number of nodes in the tree is in the range 2 up to 10 to the power 5. So 10 to the power 5 is a decent large number. So the second item is on the value range on the nodes, so that's not that essential. So the third one is very essential. All the node values are unique. So this actually determines how we write the code. So the last two items basically are consistency assumptions. So P does not equal Q, so it makes good sense. Otherwise, if P and Q were equal, so there's no good point to find LCA for a same node. So P and Q will exist in the BST. So this is also an important assumption. The reason is that so this actually determines there is always a solution or return. So with that said, let's look at the method we are going to practice. So we are going to practice both the recursive and iterative formats. So essentially here we are doing BST traversal. So here is a comment. So this is finding the LCA for binary search tree, not just the binary tree. Therefore, we shall take advantage of the binary search property. So our plan is the following. First, as BST is a recursive abstract data structure or data type, so we first share a solution format using recursion. So as in our previous videos commented, so tree data structure provides us good cases for practice recursion. So let's change this practice to be practicing. So secondly, some friends might want to understand finer details. So to accommodate them, so we shall also share an iterative format of solution. So essentially the two formats of solution are the same thing. Both are different formats of traversal, same traversal in different representation, I would say. So the code will speak itself, so we will go directly to coding. But one point we shall grasp. So all nodes values are unique. So this actually has some implementations. For example, in view of the BST context, so it says the following. So if the root value equals one of the node values, for example, equals P value or equals Q value, or the root value is in between the two nodes values, so we're going to return the root. So this is actually very straightforward. Otherwise, we just need to traverse to the left subtree or right subtree accordingly. So in summary, this is essentially a BST traversal problem. So with that said, I guess we are ready to write the code. So first, we're going to write a recursion solution. So this actually takes advantage of the recursive nature of the BST data structure. Also, we shall take into consideration of BST property, right? So first, we're going to check if root value equals P value or root value equals Q value. So in these two cases, we shall return root. Or so if so let me first write this. So this case we are going to return the root. That's for sure. And otherwise, so in other words, if the values do not exactly equal. So in this case, we are going to check if mean p value and q value less than the root value and less than the max of the two values, p value and q value. So this condition says that p and q reside in the left subtree and right subtree of the root respectively, but maybe the different order, right? So in this case, we are going to return root. So this is the case. In other cases, we want to traverse accordingly. For example, if the mean is greater than this root value. So this is one of the negation of this if condition. So if this is the case, it means that so both p and q are in the right subtree of the root. Therefore, we're going to look to the right subtree. So we're going to return self lower causes function, and then we look at the right subtree, right? So root right. So we pass p and q. Another case is that so the negation if this max is less than the root value. Less than the root value. So in this case, it means that both the two nodes are in the left subtree of the root. So we look to the left. So self lowest. So we're going to call the root left and then pass p and q. So up to now, actually, it's already a full solution to this problem. The reason is that p and q will exist in BST. So we always have a solution. So with that said, I guess let's first do a special case check. Yeah, it passes a special case, I guess. Now let's do a generic case check. So yeah, it passes all the generic cases. So now let's look at the second solution format. So here I'm going to use iteration. Let's copy this function signature. And then I'm going to change this one to be v1. So now let's look at here. So first, let me make some annotation. So here I'm going to use an iterative format. So for this, actually, it's a translation of the first solution. So, but we write or represent the code into an iterative format. So first, so because of this iterative fashion, so we're going to use a while loop. So while root. So what we are going to do is that we check the root value against the p value and q value. If root value equals p value or root value equals q value. So in this case, we are going to return the root. So this is the if corresponding to the first if above, and then the else condition. So in other words, the values are not equal. Then we're going to check if the mean. So let me copy this one. I'll directly copy this two line. So if this is the case, so I'm going to return the root. So this is the routine. So now we consider the negation of this condition. In other words, the mean is larger than root value, or the max is less than this value. So let me write this. So if the mean is larger than this value, it means that the two nodes p and q are in the right subtree of the root. Then we're going to look to the right. So we're going to reset the root to be root right. In the other case, so we're going to set root to root left. Notice that we have already considered this case, right? So this else corresponding to the max is less than the root value. So with that said, I guess, so we are already finished the second format of solution, because there is always a return due to the last constraint here. So with that said, actually, let's do a special case check. Yeah, it passes the special example. Now let's look at generic case. Yeah, it passes all the generic cases. So here, I guess, before we end, let's make some small remarks. So first, this condition, is actually essential for the solution format we give here. And secondly, the two versions of solution are essentially the same thing, but in different representations. So here the main thing is that we shall take into consideration of the BST property, right? So with that said, I guess that's all about this problem and this video. Thank you very much.